that was the last general science update, and now we're moving on to the next kind of theme, which is kind of technical topics, techniques. Yeah. All right, so Bryna's going to start it off with summary of Pyuvdata.
So Pyuvdata is a software library that is fairly foundational in that it's not really going after science. It's trying to enable other people to do science more efficiently. So the motivation for the software lies in the work that Danny did for his 2016 paper comparing the different EOR pipelines in MWA. And I think everybody involved would agree that this is a really painful process. It took 2 years. It was really hard, and it's not reproducible. It could not be done again if anything changed. If you changed the processing, if you brought in new data, it was just really hard. We learned a ton, though. It's an extremely useful exercise. But we wanted a way to make this kind of thing less painful. So the initial goals for Pyuvdata were for well-written, stable, and highly tested code that would reliably convert between visibility file formats used by the MWA EOR community. So UV-Fix, Myriad, and FHD was the initial goal. We also wanted to provide a Pythonic interface to visibility data and associated metadata to allow simulators to write files that were readable by analysis pipelines and to support future analysis development. So Pyuvdata has come out of that. It's built on PyPy and Conda Forge. There's extensive documentation and tutorials on the Reason Stock, and the software is peer-reviewed and published in the Journal of Open Source Software. I think what has been most exciting and important about Pyuvdata is the deep community engagement, and this is not just within the EOR community, actually, but and not just within MWA. It's really been across a number of different telescopes. We have 32 unique issue authors and 20 unique committers. 25% of the issues and 30% of the pull requests have been authored by scientists not in the original development team. It's been used on a number of different telescopes now, and we really want to be as widely useful as possible. So please, if you're at all interested in using Pyuvdata in any way, talk to us. So what is Pyuvdata? The main class of Pyuvdata is called UV-Data. It's a container that holds visibility data and metadata. Notably, it is a separate container. It is not contained in the file format, but it reads and writes most of the standard file formats in the literature. This dashed line on writing to measurement sets is because it's in process. And we've also defined a new file format because, of course, we need one more, called UVH5, which has been adopted for HERA. It's an HDF5-based file format, and it really enables some nice functionality in terms of partial reading and writing for large data sets. We also have partial reads on a number of these other file types. It has come to be a lot more than a file converter. It's by community request. We've implemented a number of useful functionalities. It goes to low level, so for splitting and combining, phasing, conjugating and reordering, basically manipulating the data at a low level, to visibility level, in ways that made it easier for downstream processors to work with it in a number of different ways. There's a lot of other things, some nice functionality for handling large data sets efficiently. One of the focuses of Pyuvdata is reproducibility. We have, I think, it's fair to say, very thorough human-friendly documentation, including a lot of memos on specific aspects and file formats. Very robust testing, so better than 98% unit test coverage. The number of external loopback tests through FHD and CASA, phasing validated, continuous integration so that all tests are run on every push. We have been very scrupulous about keeping track of full version information, including dip hashes, being reported into the data files themselves, so you can always know what version of software was run. And all developments go through a pretty robust code review process. Pyuvdata was seen as successful in the HERA community, and the HERA code standards were based on the Pyuvdata approach. And so there's been a real push in HERA to adopt a number of the practices that we've developed, that we've adopted, not developed, adopted from best practices of the software community in Pyuvdata. And Pyuvdata continues to be a test bed and implementation example for HERA software in terms of seamless integration, testing, documentation, packaging, etc. And most HERA code uses Pyuvdata as a foundational library for reading, writing, and accessing. Unfortunately, success tends to breed more demand. So Pyuvdata is extended a little bit beyond its original mandate. And actually, we got an NSF support for this going forward. As soon as we were able to allow people to interchange visibility files, people started talking about wanting to be able to interchange everything else. Calibration models, theme models, array layouts, program models, DOR models, and on and on. So there has been some sort of development along some of these aspects. UVCal is, I would say, in beta. It's very similar to UVData, except it supports calibration solutions. And it works with both redundant sky-based calibration. Again, we ended up finding a new file format, which was based on a file format that the US MWA, or the MWA EOR team developed in LA. If people were there, it was a text file format that was a little bit painful. CalFits is basically a text file format, only made much more efficient. This is not as fully developed as UVData, but there is a fair bit of functionality there, and we're always eager to hear if there are other things we can provide. There's also UVBeam. The push for this really came out of HERA. The number of different people were developing beam models and trying to be able to compare them and give them to simulators. But we were careful to develop it to support phased array beams so that the MWA beam integration is in process. And again, we ended up defining a new file format, as always, but we started to be able to read out the file formats that are out there. We have some future plans that you guys can read about. I'll put this up online so you can look at it. But I think the biggest thing for UVBeam is the full MWA beam, which is coming really soon, and for UVCal is sort of support for the calibration solutions being applied to data objects and for hybrid calibration models. There's also a handful of other things in the works. This has started to be developed, some of the thinking behind has been developed, but I think there are ways out. Sky model class support extended objects and diffuse models in addition to point sources, and basically providing having a thing. And then also telescope class, which is smaller, but allowing full specification of array layouts and beams, including sort of heterogeneous elements and things like that. The vision is really that we can provide all of the parts that you need to go into a visibility simulator. Calibration solutions are a little bit arguable about that, since we want to simulate stage, which we do. But also to pull all of the products out of our various EOR analysis pipelines and be able to swap and compare these different products between pipelines. So beam objects, data objects, so I've got 3 up here because some of them are uncalibrated and some of them are simulated, sky models and calibration solutions. So I'll stop on the last slide. You may have noticed that the URL for Pyuvdata includes the GitHub organization, the Radio Astronomy Software Group. This is a home for software packages of broad use in the community. They're not telescope or analysis specific. And we have a real focus on reproducibility and following and formulating best practices in software development. And there's another talk about one of the packages in this organization, Hazeiton, tomorrow.
Time for a few questions for Bryna.
You don't need to have them now, you can put them on the issues. Yeah.
Well, one of the great things is work with Pyuvdata reading. Yeah. If you do anything that's not well spelled out within the format, etc.
If the community wanted something that's flexible, would that be helpful?
I think so. I think that we've been actually quite flexible in accommodating a number of different use cases, and I think the thing that we are a little bit rigid about is it has to be well-defined. There have to be well-defined meanings for things, so that you can write down in docs, in a human readable form, what is it that this does and what does it represent. But I do think that there's a lot of scope for supporting as broader a use case as possible. I think the focus has really been on being very clearly defined and defining tests for those ideas.
One more comment on but it's just fascinating to I've seen it organized much much easier for somebody to something like this simulated facility, drop it into an analysis and have it actually take pictures and use it. That's so much easier. That sounds so easy, but some of you have actually tried that. A number of times that failed, and it all fails on little things because the simulator didn't necessarily define what day it was on and thus what the phasing exactly was, or some other little thing. And the documentation is actually extraordinarily beautiful in terms of going through that, and in fact, to the point where it really helps you thinking of, oh yeah, and then once you get it in there, then everything can read and write it. It's actually kind of, so it's been used that way, but I think it's about, there's a lot of, it really has made the interchange much easier for people, and it's certainly actually been a training thing as well, because it helps people be much clearer on their thinking, because it turns out visibility is not enough, even though you face things, even though these other things, and once you find, just write that down, find it, then you can consider these other things, but putting it in that format really helps people there.
I'm just curious if you could say more about the plans for the calibration part.
Yeah, so we have, I think, a well-defined object. We put it together with working consultation across a number of groups that use calibrations in different ways. What it doesn't quite yet support, and we've been working on discussing with the community how to add it, is the direction appendix aspect. But it does support direction independent, both in terms of gain solutions or in terms of delay type solutions. And there was a lot of work, there hasn't been as much work on it recently, there's been quite a lot of work in terms of making file formats that were sensible and usable by lots of different pipelines. So I guess what aspects are you looking for?
Kind of sort of low-level operation on existing calibration tables, filtering, all of it.
Oh, yes. We have some of those kinds of utility methods in there. I didn't mention that. We have some, and we'd be happy to add more. Like I said, we actually have some funding to support that kind of thing. So if you reach out to us on GitHub, we'd be happy to try to figure out how we can best support that.